Projection lithography is the process of transferring a pattern onto a surface using light. Today, this concept is used to make small components such as computer chips. Whilst projection lithography is used to produce many state-of-the-art components today, it has a few major drawbacks. It is only suitable for producing flat images on flat surfaces. It is very susceptible to contamination from the manufacturing environment. And it is extremely expensive for images with high resolution, which is becoming increasingly desirable. The HoLiSTEP project aims to overcome these fundamental limitations of projection lithography using a new technology, sub-wavelength holographic lithography (SWHL), to harness the wave nature of light. This disruptive technology will make lithography cheaper, simpler and more eco-friendly, on top of enabling higher resolution on three-dimensional products. In traditional projection lithography, you need a light source, complicated illumination optics, a projection lens, which is an even more complicated system that can consist of up to 40 optical elements of high quality and precise alignment, and a projection mask that has an extremely complicated structure, especially for high resolutions. Light goes through the system, called a projection stepper or scanner, and produces two-dimensional images on a photoresist. In holographic lithography, you need a source of coherent light and simple illumination optics. You do not need a projection lens. Instead, you use a holographic mask that has a very simple, regular structure that acts as both a mask and as a projection lens. Light goes through the system, and after the diffraction on the elements of the holographic mask and interference, produces not only two-dimensional but also three-dimensional structures at one exposure with high resolution. To do this, the HoLiSTEP project will develop and integrate several critical components to progress the breakthrough technology from demonstrator tool to an industrial stepper. A high-power laser with a large length of coherency will be developed to work at 345 nanometers. Adaptive optics with a novel wavefront correction system will be built to provide higher precision, higher stability, and high-power operation. A new holographic mask will be developed to manipulate the beam through diffraction and interference, eliminating the need for projection lenses. A new precise alignment system will ensure that the beam, holographic mask and wafer are lined up perfectly. HoLiSTEP presents the first true 3D lithography technology and will overcome current limitations in the fabrication of microelectronics. This unique capability of SWHL will find its application in such areas as micro-electromechanical systems, micro-optical components, sensors, photonics, meta-optical components, and advanced packaging, made smaller and more efficient than before. The freedom to produce 3D structures in thick, photosensitive materials on non-flat surfaces will benefit many industries, including optics, photonics, the automotive industry, and more. Moreover, as only the stepper and masks are required, holographic lithography can easily be implemented in existing production lines. Compared to masks in conventional lithography processes, holographic masks are significantly cheaper for high-resolution and three-dimensional products. This will enable fast development and diversification of product ranges and will make the technology more accessible and affordable to innovative startups. And because our holographic stepper uses fewer lenses, the masks are much more durable, meaning less waste is produced. HoLiSTEP brings together expertise from 9 academic and industrial partners across Europe to empower a positive transformative effect on the environment, the economy and society by enabling a wider range of companies to produce novel 2D and high-resolution 3D images at lower costs.